to a dashboard because it's not yet there? Can you just
It's quite easy because all the information are text files, are JSON files. So you don't even need to learn a new database type that I imagine was good. Everything is very, very easy in JSON file. 100%.
And the information is very well organized by exchange, market, date, year. So everything is very fragmented so that you can easily pick from any process that you build the information that you need.
More questions? No? You know everything.
That's a lot to digest. Maybe we can make a little break at some point, and then come back maybe for more questions, and then decide what else.
Okay, so the cost here, our Turkish friend cost. What's next cost? Let's have a break?
Yes.
Yeah. Okay. The boss says break.
Yeah, sure.
In the tutorial, how can I interrupt it? Because I think I ran a little bit too much data. Because with the default data. Okay. So all of these things are tasks. Yeah, I thought about that, but then I saw, okay, it's not a lot of data.
Yeah. I'm going back to
So where would you change it? Like, the amount of data that they can find,
giving that out to
they're working a lot on this.
people that have and then we can create indicators, and then they can bring users as well, and they can make sense for them as well.
We're not going to use the projector now.
So you can turn on the light.
The lights.
Okay, I will talk a little bit about the machine learning part of the platform. Okay. The first part of the platform that we talked about was unrelated to machine learning. Okay, what we explained in the morning was about designing. What Carl was showing was what we call the designer space, where you design everything is designable somehow. You can design the strategies themselves, but also design the process that defines the operation. Okay, your trading operation, your data mining operation. He also showed us the charting system where you can plot all this information and you can see what is going on. Okay. And in all that execution, machine learning was not involved in any way. Okay, so this last year we were looking for a way to start using these technologies to take advantage of that. And so we wanted to answer one question, that is, there are many possible ways. People familiar with machine learning, you know that there are many possible ways to use these technologies to improve your strategies, right? Creating machine learning models to make predictions, essentially. Okay. So, and machine learning as a science or a sub-science of computer science have many different branches also, right? So one of the first things that we wanted to learn was if it was possible to predict. We came with a very simple question. Is it possible to predict the next candle using machine learning? What do you think? Is possible?
No,
No.
it's impossible. Only price, it's not possible.
And is it possible if you add some indicators into the mix to predict?
Another process, another mode. We will add something,
More data.
more data.
Okay, but the question then is, which data is the right data to be able to predict the next candle? Which data is the right data?
Not in the price, maybe RSI, not in the all of the mathematical form. Another option, maybe social media, another function you should add.
Okay, so that's your guess, but nobody really knows. Okay, so I didn't know and still don't know, but that was the question that we started from. Okay, how do we predict the next candle? What is necessary as a data source? Okay, and which information we can feed or train a machine learning model to produce accurate enough predictions that can be useful, because no machine learning model predicts things in 100% without any error. In fact, the error is part of the output of the training process. Okay, there's always an error, 0.01 or 1% or 10% or whatever. So the question is, how do you minimize the error? Okay, how do you produce a machine learning model with the minimum possible amount of error that predicts, for example, the next candle? Okay, so we started with that question, and we soon realized that there's no easy answer, and probably the only way to know if it's possible is to try it out. Okay, it makes sense. Okay, you said that is with social data, sentiment data. Okay, then maybe we should try it out. Some people say probably enough indicators based on price, maybe with order book data. Nobody knows. So how do we try? Okay, if we go and write a Python script for creating machine learning model, and I start trying things out, the first thing that you will notice is that each time I want to try one set of parameters or a new type of data set, depending on the hardware I'm using, I might spend 1 hour waiting for the model to be trained, right? So, because it's a very computer intensive process, training a machine learning model, and I'm talking with only a few data. If you put a lot of data, might be much more, okay? So, and on top of that, you don't only have possible different data sets that you can feed your training process, but also there are specific machine learning parameters, okay? Like the number of epochs, the number of whatever. There are many different parameters that may impact the level of error that you can get for your machine learning model. So then the next question is, okay, so how do I know that the parameters that I use are the right ones? Maybe I change parameter number 3, instead of 100, I put 200, and the error, instead of being 2%, is 1%. Who knows? There's no way to know until you test it, right? So essentially we have a problem where nobody can know which is the best model for predicting this without testing many different options. Okay? Then when you realize that, then you ask yourself, okay, maybe if I could get the help of some other people in the community, maybe we can split the problem, and you test these options, you test this one, we change this data in this way, and you test this, and maybe the 20 people here are testing different scenarios, different cases, and maybe one of us find a better combination. Okay, so it's a kind of combinational problem. solve. Okay, so with that in mind, we start developing a way of how we can crowdsource the testing of different machine learning cases to see which one can produce the machine learning model with the less possible error. Makes sense, right? No? Doesn't make sense?
It would be more efficient to use another machine model.
A what?
It would be efficient to use another optimization process to do it instead of using people.
Yeah, but also, but with the same idea, you can use both things. You can use people and optimization model if you take it further. You know, the thing is that there are too many combinations of stuff because you don't know if it's going to work with 1 hour candles, or you don't know if you put 1 hour together with 2 hour candles is the best solution. You don't know if it is with 1 minute, with 24 hours. You don't know, you have hundreds of indicators to pick from. So really, there should be a way to organize this in a certain way. So what we did is we created within Superalgos a specific project that we call it Bitcoin Factory, to put it a name, okay? But it's very much related to trying to solve this problem. So inside the context of that project, we created an infrastructure for crowdsourcing the testing of different combination of data sources and parameters. Okay, so essentially, I'm going to draw this so it's a little bit more visual. We created a concept of what we call, put it here, test server. Okay, so too small, bigger. So this is not working. Test. Okay. But what is a test server for in this situation? Well, it's a program that connects to the rest of the platform of Superalgos and is able to extract from it information from indicators, meaning candles or any of the indicators that people can build there. Okay? So it's feeding from the output of the infrastructure of data mining. Okay? And whoever is running a test server can define the ranges of parameters you want to test to see which one produces the less possible error. As an example, I could define, if I'm running a test server, that I want to try, I don't know, the time frame of 1 hour and 4 hours. Okay? And I want to do it with, to make an example related to machine learning specific parameters, I don't know, with 100 epochs or 500 epochs. Okay? And because I am the operator of the test server, I define which are the different ranges that I want to test. Okay? 1 hour to 4 hours, 500. And like this one, imagine 20 or more parameters that defines the machine learning model, essentially, which is the data sets, and also the different combinations of parameters that we want to test. Okay? So, as I'm running this test server, I'm going to produce a list of different combinations of parameters. Okay? So, in what we call test cases. So, test case number 1 will try only with 1 hour time frame and maybe with 100 epochs. Test case number 2 will use 1 hour but 500 epochs. Okay? So test number 3 is going to try all the different combinations, and probably combinations of indicators too. Maybe test number 1 uses Bollinger Band, whatever, and test number 100 using RSI, whatever. Okay? Whatever I want to define. So the test server produces at least thousands of different combinations of parameters and compiles the data sets from the mining operation into a file that can be sent to whoever is going to produce, who's going to test it. Okay. So let's say that all you people here want to participate and try to see which of all this combination is the best situation. Okay. So for that we have what we call the test client. Okay. That somehow is going to connect to the test server and is going to request the first case. You will get case number 1, case number 2, number 3, number 4, and your computer is going to be running for 1 hour or more, depending on your hardware, and it's going to get a machine learning model trained with these parameters and this data. Okay? So then your machine is going to report back and say, okay, this is the machine learning model that I got, and I can see there is a 1% error in the prediction. Okay? Because that's the result. Okay? Maybe you make your test with your parameters and your data, and you find that you can do it with 2% error. And everybody is doing the same stuff, and he's finding that he can produce a machine learning model with a specific set of data and parameters with 0.5 error, okay? In predictions that models can make. So the test server is compiling all these results, and it remembers which one are the best ones, okay? Perfect. So there we have a crowdsourced mechanism of testing this with potentially a large amount of people participating, finding the best model that can predict the best possible way, which is going to be the next candle. Okay? Then on top of that, we need a mechanism to produce the forecast, okay? So that people can consume this forecast and use it in their strategies. Okay, if you're running your trading bot, maybe you're evaluating several conditions, but one of those conditions is what is the prediction of the next candle, and you take it into consideration and you give it some value to that, and then you use it or not depending on whatever your strategy is. Okay, so to get those predictions to you, the idea is that we are not going, we are having another module, this is another module, that we call the forecaster. So essentially the forecaster is a software that connects also to the test server, but instead of getting test cases, it's going to get what we call forecast cases. Okay? A forecast case is essentially the parameters needed to produce a machine learning model, but that has already been seen by somebody in the crowd to be the best possible model because it has the less error, the less percentage error. Okay? So this guy recreates that model, and every hour is going to be running the predictions of this, of what is going to be the next candle for this particular market, and it's going to send this prediction every hour to the test server, which is in turn going to broadcast this to all the people that are subscribed to those predictions. Make sense? So once you receive the prediction, you will be able to record that information, or the system record that information as yet another indicator that you can continue processing, or you can consume it via a trading strategy. Okay? Am I going too fast? This is more or less clear what is going on. Any question? Question? No?
Just wanted to know that Numera AI is doing the same thing. So they are only focused on bringing people, so there's also the token NMR, bringing people together to build the best machine learning algorithm, the best performance, and they have a continuous championship going on and so on.
Yeah,
it's quite similar.
I mean,
it's cool.
It's the logical conclusion you arrive when you ask this question. How do you get the best machine learning model? when you have at least 20 parameters that you can set in different values, and when you have any possible data source that is out there. How do you know? If you are going to test it by one person, it's going to take ages. If you divide the problem into a crowd, the bigger the crowd, the faster you find the best solution. And if you run this continuously, then maybe he found 0.5 error for the Bitcoin US dollar market, but after 3 days, maybe he finds 0.0